Hey, what's up? It is Eric again. It has been a while since our last episode, and I apologize for that. End of last year was extremely hectic and busy at work, and frankly, the beginning of this year has been pretty hectic and busy as well. But I'm back, and there's two more episodes I'd like to do in this series. I figured why not just get them done. I also have a new microphone. Hopefully, it is an improvement. Um, Here we are. Let's dive into some stuff. Okay. So we've got our little test scene here, and I wanted to cover this guy in particular. I don't know if you remember in that very first episode we did. This was kind of a weird mesh because I was able to deform it in the scene, which was not the case with most of these other meshes, which were just rigid static meshes. And there's a tool that I built to do exactly that, but rather than just dive straight in on this tool, it sort of opens up a broader conversation that I think is worth having. It's sort of a fundamental level of tools that I think every game project should really utilize. And so I'm going to jump through some of those. There's three specific tools I want to show, which will lead to this. Um, and they're tools that I would consider sort of generic use, general purpose. They're built to be very multi-utility, multi-use. The first of which is, well, it's a basic clone actor tool. So let's say you have a bunch of meshes. I've got a couple just Megascans meshes. These, I don't know, posts. We'll take this metal post. Let's say I wanted to place a bunch of these all together. You could clone them and manually and make a bunch of copies and update them, and I want them all to be rotated different or whatever. You can do all that. That's fine. But then you end up with a bunch of separate actors that are maybe hard to control. Another way of doing that is to use a utility actor like this. This is just called the clone actor, and it allows you to define a mesh and then make basically lots of copies of said mesh. I'm going to just grab this metal pole, assign it to this mesh, and at first glance it is literally the same because it's only set to do one copy. But at its very basic, this tool, I'm just going to set it to do 10 copies. Nothing changed because those copies are all right on top of each other. I can then tell it to offset those copies each step, right? So this is not rocket science. This is very basic automation, but cannot overemphasize the utility of a tool like this. This is fantastic for all kinds of things, and obviously just cloning things in a line is the simplest utility there is. But you can start combining transforms, so I can rotate them along an axis as I clone them. If I rotate them along the same axis that I'm cloning them, I can make a spiral. I can make a whole bunch more clones. Hopefully, this is pretty self-explanatory. You can get some crazy stuff going. I have used tools like this for all kinds of things, repeated elements or architectural structures that need to repeat at very distinct intervals. It's really good for having manual control over things like that. You can get kind of fun. It doesn't all have to be in a line too. So if I want them to be offset and let's say rather than offset in one direction, let's make 36 copies. I'm going to rotate them all 10 degrees on Z, which spins them around. That doesn't help us very much. But I added a little feature that is a pivot offset, so it'll actually offset first and then rotate, which is kind of nice. So we can make circular symmetrical structures, that sort of thing. You can add in some randomization as well as built in. So let's say I want them to vary in height. I'm going to scale to 0.5, so now they will randomize in height, which is kind of nice. Hopefully this makes sense. Again, this is not super complex. It's just super useful is what it is. But there's an element to this that I should talk about real quickly, which is the optimization aspect here. In game engines, most people understand the concept of polygon count or vertex count or shader complexity, that sort of thing. That all costs the GPU some effort. But one thing that usually I usually only hear game developers talking about it is the notion of a draw call. A draw call is an operation that simply switching tasks takes some computational power. And so when you're rendering a scene filled with lots of objects, you want to reduce your number of draw calls, the number of switches that it has to do between different objects. And usually in game engines, if you have, let's call this 36 different objects, if these were all different meshes or they all use different materials, those would be 36 different draw calls. But because of the way this tool is set up, I have an option to switch it from static mesh components, where each one is a separate static mesh, to an instance static mesh component, or in this case, a HISM, a HISM component. That stands for hierarchical instance static mesh. What this is it's basically a single object, rather than being in 36 different positions. It's one mesh that is then essentially duplicated at render time to be drawn 36 different times, but it's only one draw call, and the specifics don't really matter. The important thing to note is that it's far more optimal. So if you have situations like this where you have simple meshes that can be sort of turned into arrays and cloned, this is a far more optimal way to draw it anyway. The nice thing about a hierarchical instance static mesh is if you have mesh LODs on these meshes, they can each LOD independently too. So if I back up, the ones furthest from me will be the least dense, and the ones closest to me will be higher density. It's super nice. We can add some randomization. Let's say we wanted them tilted slightly different directions. Do like, call it negative 15 degrees to positive 15 degrees. Oops, that's not randomization. I should do this right. Randomization, there we go. Negative 15 degrees in X and Y, and then we'll do up to positive 15 in X and Y. And so now each one is rotated a little bit differently. Again, doing this by hand would take a long time, and if all you need is the semblance of randomness, you can get that for free. Zero effort. I can do compound arrays with this tool, so if I want to make a clone of a clone, I can turn that on, and let's start with 2. I'm going to rotate the copies out in, yeah, this axis is nice, and then we'll make a whole bunch of copies. So now we're making this crazy weird metal structure. Looks like modern art. And that's one object, and that was all done just with math and randomization. So I don't know that I would necessarily use it in instances like this to build this in game. It would be a pretty optimal way to do it. But for blocking things out and just getting cool visual experiments done, it's a nice tool to use. But the one thing about this is all of the transforms are mathematical. There's not a whole lot of hand authoring. It's numerical. And it is useful and it is cool, but that leads to a second type of tool, which is it's related in that it does automation, but it gives an element of authorship to it. And this tool is what I call a Spline Scatter tool. It's very similar to the previous one, except you'll notice it has this editable spline in with it. And I can edit that spline, and essentially it takes a mesh and it scatters it along the length of that spline, which if you use actual meshes, like I'm going to switch over to this wooden post, switch that in. Oops, do that right. There we go. All right, so now the spline tool is making these wooden posts, and they're following the spline. I'm going to set the number of meshes to 10 so we can see a little bit more clearly what it's doing. right now it's just positioning those meshes along the spline, which is fine, but I don't really have control over the angle. So I can enable alignment. Let's say I want to align the x-axis along the spline. Well, now I have options like banking or pitch. So as I manipulate the spline, you'll see the objects along that curve are following it. You can even rotate the spline along its length and see that it'll obey the twist. Hopefully this is making sense. So something like for fence posts or again, architectural elements that need to follow a very specific path. Very, very easy to do with a tool like this, and very easy to update and do it in a non-destructive way. We've got the same sort of randomization options available to us. So let's say we wanted this line of posts to vary in height. I'm going to do the same thing. We'll do the 0.5 scale. So now we get a little bit of randomness along it. Same thing with the rotation. Let's see. I think it does it in its local rotation. So yeah. So we'll do negative 15, negative 15, positive 15, positive 15. So now it's positioning them and adding a little bit of random tilt, which is kind of nice. Maybe a little too much. We'll do negative 5 degrees up to positive 5 degrees. So they don't tilt into each other. And right now I have them spaced based on the number of copies, right? I've got 10 copies. You know, if I want 20 copies, okay, cool. There's another option though, which is to use, rather than the number of meshes, to just use the distance. And so with this methodology, I'm actually defining the distance between the posts rather than the number of posts. And the utility there, let's just say I want 100 units between each one. The utility there is that I can actually just extend the spline, and you'll notice it just keeps on adding posts, right? So if I make the spline longer, it'll add as many as it needs to make it work. This is where you start to get really powerful tools built, because let's say I want to build, I don't know, a fence around this rock in the middle. I'm just going to position the spline into the ground, and you know, if I wanted to, this could be automated. I could have it project ray traces down onto the ground and automatically position the fence posts. I tend to prefer manual authoring because, you know, there's exceptions to every rule, and sometimes you need to be able to get in there and manually adjust things. So I tend to skew towards control over automation in sometimes and until automation matters more, and then we go that way. So I don't know how much explanation this needs. I think it's fairly self-explanatory. And it's related to what we're going to get to next, which is deforming meshes. But yeah, hopefully that makes sense. Oh, and the one thing I'm noticing is that they're all oriented the same way. Let's spin them randomly on. Let's do 180, negative 180. There we go. And so now they're all rotating in Z. They're all stuck in the ground randomly. So I don't know what this could be. You know, maybe these are some kind of a perimeter fence or something. That's kind of cool. And let's say we have them on the spline, but they're too perfect. We can randomize their location as well. Let's move them negative 10, negative 10. Now let's do even more than that. Negative 20. Negative 20, positive 20, positive 20. So now they're following the spline, but they are sort of moving their positions around randomly, which would be, you know, makes it look more natural. Usually, if some, you know, caveman tribe or something that's putting these posts in the ground, they're not going to have like a laser level to make it perfect. And so you can add a little bit of imperfect automation to the system while still having the manual control, and you get something that looks really compelling when it's in game. So hopefully that makes sense. That's a clone tool, a spline scatter tool. And then the next one that I want to show is a spline deform tool, which is what we were working up to. That's what this mountain thing was. Let me show you the tool first, and then we can get into its various uses. So this is actually just a test mesh that I created for this tool, which is actually a tube. It's green because, you know, all pipes should be green. It's similar to the previous spline tool, except rather than scattering a mesh along a spline, it deforms that mesh along a spline. And it can actually stack up multiple copies of a mesh along a spline as well. So in this one, it's got similar controls. I'm going to do mesh length. And so this is actually making multiple copies of a mesh along the spline. 200 seems good. So what I'm telling this is that, in fact, I can double click it and see. It's kind of hard to see with the coloration, but if you can see the orange highlight here, that is one copy of a mesh that is being stacked end to end. I can select the next one here. In fact, I can tell just because of the interface. I'm currently using 6 different meshes along the length of this spline. And it's basically just deforming each one and plugging them in end to end. But, you know, now I have this cool, super deformable tube, right? Now the benefit here, unless you do 3D modeling for a living, the benefit may not be obvious. But the important part is that I can do this deformation in the game engine rather than having to go back to 3D Studio Max or Maya or whatever my content creation program is. I'm doing this directly in the engine. And what's even more cool is that if you want, or if you're designing a game that supports it, you can update this in real time in engine, right? So you could have a hose that gets moved around, or you could have, I mean, yeah, it's an obvious tube example, but you can change that deformation at runtime. It's not cheap. You have to account for it, but it is a possibility. In this particular tool, I have end cap support too. So let's say I want to have a little mesh that sticks at the front and the back of this deformation. Now I got these sort of socket. So you can imagine a power cord or a pipe or whatever. So that's basically how the tool works. I'm going to switch to a mesh that has these ridges running down it to show that this also supports like twisting along its length. I have it's doing a little bit of a twist now because I think the spline itself is twisting. You can see that sort of twist deformation. Hopefully you can see that. I can also tell it, where's my start? Roll, end roll, there we go. So I have controls where I can actually just procedurally twist that along the length as well and get sort of a drill screw thing going on. And that's great for meshes like this. But what I find is this tool is extremely useful for organic shapes as well. Like if you look back to the early video in this series, you'll see how I was manipulating this this piece of rock. This is, you know, there's only one copy of it, but this piece of rock and just deforming it the same way I did this tube over here. And I only have one copy there, but if I wanted to, this will be very ill-advised. I'm going to turn off scaling. I'm going to turn off banking, and I'm going to extend this spline to be longer, and then I'm going to tell it to do 2 copies of that mesh. Or let's do 3 copies. So now it's stacking this mesh up 3 copies, one into the next, and this is a great way to make, say, coastlines or cliffs, or I mean, hopefully this doesn't need a super amount of explanation. You can end up with some tools that are extremely flexible and extremely dynamic, and again, for me, non-destructive tools that let the artists make changes mid workflow are superior. One caveat to this mesh deformation tool, when I was talking about draw calls earlier, I was talking about how if a mesh is the same mesh, it can be copied and repeated very cheaply. One downside to using custom deformed meshes like this is, even though this is 3 copies of the same mesh stacked one next to the other, again, you can sort of see where one mesh starts and one mesh ends. Here I will add. I have an option here for mesh overlap. I can do this so you can see where those 3 meshes are a little bit more clearly, right? So these are each being deformed uniquely, which means I'm not going to be able to draw them all in one draw call unless I merge the meshes into a single mesh, which I can do. Cyan has some custom post-processing tools we can use to do exactly that, but generally you have to keep that in mind when you're doing, if I had lots and lots of meshes that were deformed this way, I would just have to understand that, okay, that's going to cost me X number of draw calls or whatever. But anyway, yeah, so you can see why I add this mesh overlap, as I don't want to have a clean break between the two. So I added an option that will actually just jam the meshes into each other a certain amount, and depending on how far you do it and depending on the type of mesh, you can get basically invisible seams, which is kind of nice. So that is the mesh deform tool. Everything we've gone over in this demo today, I should state, is basically Unreal out-of-the-box functionality. These are custom written tools, but there's nothing stopping anybody out there using Unreal from writing these exact same tools yourself. In fact, these versions of these tools I've been using for years. They're some of the first tools that I started writing in Unreal. You don't really need to be a super deep level programmer to do this sort of stuff. It's all just if you're using Unreal, look into construction script automation. It's just when objects are being built, that's when most of this code gets run, and it's super approachable. I would encourage you to dive in, give it a shot. You can kind of teach yourself this stuff if you just use common logic, but very, very powerful. And I would recommend anybody who uses Unreal or Unity or any game engine for that matter, invest some time in writing tools like this, because they will help you when you need it. I think, let me switch back to this guy here. I think that about covers it for today. I have one more video in this series I would like to do, and I will be getting that done real soon. Thank you so much, and have a happy new year. I hope you are well, and we'll see you soon. Thanks.